Hey there, welcome back to another episode of the Barnabas Robot Arm. I'm excited because in this episode we're going to start using these four knobs right here. Okay, so these knobs are analog knobs, or you call them potentiometers. That's another technical term for them. The thing to know is that they're able to change the intensity of something. So think of like a light that you can dim. You can make it go super bright and also make it dim, like halfway light, uh, barely on, half, three quarters on, and then all the way off. Okay, so some lights are just on and then off, but some you can dim. Another thing that you can change the intensity of that's pretty common is like volume. So there are still some devices now, but back in the day, all the devices like radios and stuff, they would have this a dial like this. So if you wanted to change the volume, you would turn it all the way up, like crank it up, or crank it to the middle, or somewhere in between, or turn it all the way off that way. Okay, and so that concept is called analog. So digital, the opposite of analog, is something that just goes on or off. Okay, so it's just that's very simple. Now analog, if you want to get the in-between values, you're going to need these dials, which would be called a potentiometer. All right, so what we're going to do is make sure that these dials work. That's number one. And then number two, we're going to connect using code the dial to each of the motors. We got four dials, four motors, so that we got one motor for each dial. All right, so let's go to the code and check it out. All right, so this is the code from before the previous video, so I won't go into all this yet. The new information we need to see if our dials work. All right, so if you look at the dials, if you look at the bottom right there, or maybe I'll change screens here. Okay, if you look at the dial, you have control 1, 2, 3, and 4. It says it in white writing down there if you look closely. Okay, so let's do this. Let's go to setup here. We're going to do a serial dot begin 9600. Okay, this is so that we're able to send a message from our Arduino back to our computer. Okay, because we want to be able to read out what the dial is sensing. Okay, so let's go. And so we did that, and then in our loop we're going to do this. I'm actually just comment out all this stuff, so I don't need to make any moves right now. Let's just do a let's see, serial dot print ln analog read 0. Okay, make sure I got my parentheses here. There. Okay, I'm going to delay 100. Okay, so it's going to print out analog read 0. Now why 0? Well, the way that the analogs is connected is that if you look on the blue board underneath the Arduino board, so not the green one on top here, but underneath there, you're going to see A0, A1, and so forth. So the analog, it just starts at 0, so that's the one that's connected to this first one, control 1. I think. Well, we'll see. All right, so analog 0, and we're gonna delay 100 so it doesn't send a bunch of messages non-stop. We just want to send a message to the computer, chill out 100 milliseconds, and then it's gonna loop. All right, let's see what we get here. I'm gonna upload. Okay. Now to see the message back, we're gonna have to click on monitor over here. So let's click on that. Connect. Alright. Okay. So I'm seeing 234 but it's not continuing because, okay, because of this infinite while loop right here, right? So basically it's just doing it one time and it stops. I want it to keep looping, so I'm going to get rid of this. Okay, now it should just keep looping. Okay, go back. Good, go to my monitor. Cool. So you see it's saying 230, 31. Let me rotate this dial here. Make sure you can see. Cool. When I rotate it all the way one way, it goes to 0. See, you see it getting larger as I rotate the other way. See how large it gets. And it goes up to 1023. Excuse me. 0 to 1023. Cool. Now, the reason that it goes between 0 and 1023 is because it's a 10-bit analog input. Okay, so you can, I won't spend a lot of time on that right now, but you can look up why does 10-bit equal 1023. Okay, why do you get 0 to 1023 for a 10-bit analog input? I'll give you a challenge. You can look that up, Google that up yourself. The hint is that it has to do with exponents. Okay, so check that out. For you right now, what I want to let you know is that the bits, the number of bits for an analog input gives you the resolution. Okay, the more bits, the more resolution you get. So imagine if we went from all the way to 0, I'm turning it all the way to 0. If it went from 0 to like, let's say like 10 or something, then you don't get that many different segments, right? But if you get 0 to 1 million, let's say the maximum was like 1 million and it had all the numbers between 0 and 1 million, then it'd be super fine, right? It's just like TV. Okay, so you have like an HD TV. It's like super clear because you have all these different pixels that are across the screen. The more pixels or dots across the screen making the image, the more clear, the more real it's going to look. So that's the same idea here. All right, so we have 10-bit resolution, which gives you 1024 different segments. It's 1024 because even though it goes to 1023 here, what does it start at? It starts at 0. I know it like goes up and down a little bit. Don't worry about that. That's just, there's a little bit of noise, electrical noise. We don't need to worry about that. But yeah, it starts at 0. So 0 to 1023, it's actually 1024 different segments on our 10-bit analog input. All right, Google it, check it out. You can learn more about that. If you have questions, of course, you can reach out. Okay, so that is control 1. Let's do the other ones, right? Let's make sure that they all work. Just copy this. Or maybe I'll just do this, right? Analog 1 should be the control 2. I know it's a little confusing. Just subtract 1, but I think we could do this. Okay. This is number 2. Down to 0. Cool. So my number 2 control works. Let's try number, so the analog 2 would be for control 3. Should all work. I just want to make sure, right? And you should make sure as well, because later when you have code, you might be wondering what's going on here, and maybe it doesn't work for some reason. Okay, this one here. All right, my control 3 knob, it goes to 1023, goes to 0. Cool. Control 3 works. And let's just make sure, see if I touch control 2, it doesn't change, right? And also control 1 doesn't change because my code right now is sending info on control 3 only. Okay, let's test the last one, which is control 4, but we analog read 3. Okay, this will work, I'm pretty sure. Whoa, okay, we're just homing. Okay, yeah, cool. This is control 4. Okay, I like what I'm seeing, so that all works. So let's make a comment here, right? So analog read 0 is for control 1. Analog, this is just some notes for us. Control 2. Analog read 2. Control 3. Analog read 3 is control 4. Okay, and what else did we learn? This will help us in our coding later. Range of analog is 0 to 120, 1023. Okay, so that helps us. And then let's also do this. Let's assign, because we just make control 1, that's going to be base motor. Control 2, let's do tilt motor. Control 3 is going to be the extend motor. Control 4, it'll be the claw motor. Okay, now let's have some fun. Okay, so let's do this. Let's control the base. Okay, so let's do if I'll do it in a comment first. Okay, if analog, if 0 analog read, I'll just say it this way. If control 1 equals 0, go to angle 0. If control 1 equals 1023, go to angle 180. Okay, so if I turn it, if I control 1 all the way to one side, it should go to 0. All the way to the other side, it should go to 1023. Let's now write the code for that. If, now control 1, going back here, is controlled by analog read. So if analog read 0 equal 0, because equal is it's not a statement, it's a question. So at any time we want to ask a question, does this equal to that, we need to use equal. If that's true, then I want to move base. Okay, I have my nice functions here, right? Move base to 0. Boom. Okay. If analog read 0 equal 1023, move base 180. And I'll get rid of the serial print because I don't need that anymore. And cool. So then now this will just keep looping. It'll keep looking at analog read 0. And so at any time, if it becomes 0, it's going to move it to angle 0. If at any time analog read 0 becomes the maximum value, it's going to go to 180. Okay, let's try. Okay, all right, I'm gonna move my analog 0. I'm gonna make sure I don't get hit by my robot arm. So I'm gonna move it, make sure you can see, turn it all one way. Oh, it worked. Okay, then let me turn it the other way. Sweet. And then back the other way. It's working. Now I would like it to go a little bit faster just cause. So I'm gonna do, you remember the increments? I'm going by increment of 5, delaying by 100. I'm gonna say delay 20. I think it'd be a little smoother motion. Yeah, I like that. Sounds good too. Cool. And then other way. Sorry, you know you can't see that way. There. Sweet. Okay. Now, like, let's see if I can go in the middle. So if I can say, if analog read 0 equals what's in between? What's the halfway mark between these two? 0 and 1023. It's around 512. Okay. Then move base 90. All right. So then it should go halfway if I'm like halfway in between. Let's see. Okay. Oh, cool. That worked. But I have to go slowly, right? Because if I go all the way, boom. I love it. I'm like addicted to this. Okay, halfway. Sweet. Now I'm curious, like, what if, can I do like a quarter of the way? Would it work? Let's see. So if analog read 0 equals 256, which is like a quarter of the way, let's move base to 40. And then if analog read 0 equal what is it, 768? Did I get that? Am I doing that right? 768. Move base 135. Okay, now we're totally out of order. It's confusing, so I'm gonna just put it in order. Okay, this is pretty cool, right? Oh, messed up somewhere. Oh, spelled that incorrectly. Okay, sweet. Okay, I got. Oh, that's halfway. Or now it's halfway. Yeah, check it out. Nice. What if I do it really fast? Yeah, if I go really fast. I go slowly. Yeah. So sometimes if you go super fast, it might skip one of the angles, right? Because you're like zooming past that analog value. But it's pretty good. Okay, so now I have that. Now what if I just copy this code here, but for the tilt motor. Let's try. I'm gonna copy this entire thing, paste it here. Okay, that's a lot, a little bit too much. I'm gonna undo that. Let's clean this up a little bit. I'm gonna put a comment here. It says base motor. Okay, and kind of put these all together here. And I'm going to show you a trick here. Because there's only one statement here, you actually don't need these curly braces. It's kind of a shortcut, so watch this. You can just do that. You see that? So because now if you had multiple commands here, like you have move base and then want to do something else as well, then you can't just not have those curly braces, okay? But the reason I want to do that is going to make our code cleaner, okay? So see that? Looking super clean now, right? Okay. Now, well, first let me make sure that this works, because if it doesn't work, I got some work to do here. Okay. And then let's go fast. I'm excited. Okay. I'm gonna copy this. And let's do this for the extend motor. No, what was the next one? Tilt motor. So I'll just change this to move tilt. Now you might be saying, Mr. Ed, you can't just put 0 to 180 for the tilt motor because the tilt motor only goes 180 to 120. Well, the good thing is we have these protections in our code, remember? That it won't allow you to go beyond the limit here. That's what's so beautiful about the code we wrote. We don't even have to worry about it because it's protected. It won't let it go to a place that's going to hurt the robot. So I'm just going to leave these numbers in there and we know that we're safe. Well, at least should be if my code's working. All right. And, oh, I made a mistake. It's not analog 1 or 0. It's analog 1. Right? If you look at our notes here. Analog 1 for the tilt motor, which is the control 2. All right, so now we got both going. Let's see. Okay. Cool, it's doing something. All right, so let's first bring this guy to the middle, and then let's pretty cool. I love it. Okay, now extend motor. You see I just copy and paste, right? This should all be 2 now. Oh, not extend tilt. Move extend, right? Copying it and pasting it. All right, we got 3. Okay, got my base. Cool, and then let's do that's working. So that's the tilt, and now extend. Oh, sorry, no, that was oh, this is extend here. Okay, and this is the tilt. Cool. And then now just the claw. Copy. Okay. All right. Let's go. Okay, base. I'll go with a bigger image here. Base. Okay. This will be extend. We have. Sorry, I kept messing this up. This is extend. The first other one was tilt. And then let's check out our claw. You can see top view, claw. Sweet. It all works. All right. So I would say, I mean, you could just stop right there and say that, you know, I love the robot. It's pretty cool. You could just plug it in now without a computer, and then you could just grab whatever using these. Now, and when I say plug it in, plug in the power supply on either one of these power jacks here. Now, there are some improvements though, right? Because if you look at our code here, for example, the tilt motor, we're telling it to go from 0 to 180, but as we discussed, tilt for me only goes to 180 and 120. So what does that mean? That means even though it's protecting our code, like our code protects our robot from going beyond the limit, 0, like this move, and this move, they do nothing, right? Because our code says I can't go to 0, I can't go to 40, I can't go to 90. So that means from 0 to 512, it does nothing. So what I'd rather do is have the tilt motor, our code, be able to get all the angles in between the limits. So that would be in between 120 and 180. So how would we do that? We need to modify our code a little bit. So I'll save that for the next video. For now, all we need to do here is just follow my lead. And once we have that in, it's working. We're gonna tweak it a little later to make it even better, but you should be able to control your robot to like pick up an object, right? Let me see if I can, like with this knob here. Okay, so here's a little paintbrush here. So now I can, let's see if I can figure out. Oh, okay, it's a little fast. See, if I fine-tune my code, I can get some more like fine-tuned movements, right? Because right now it's a little bit rough, okay? Because it's like it's either gonna, yeah, see, I can't get it to be right here because I need to update my code a little bit, but you know, you kind of get the point. So let's just say we go down there. Let's go ahead and open my claw, and let's close my claw. Cool. And then let's lift it back up. Okay. And then let's open my claw and drop the item. Okay. All right. So, you know, it works. We can improve it. Another thing that, just as a sneak, kind of a sneak peek into the next video. If we look at the code here, we're using these equals, right? So what we're saying, for example, right here on line 139. We're saying analog read equal 256. We're saying that the analog read needs to be exactly 256. And if that's the case, then we're going to move to 40. So that seems to be working, but here's the thing. When you're working with these analog, these dials, it's not always the case that you're going to get exactly 256. Because if you remember earlier, there's like noise on the analog, so that sometimes even when you turn it all the way to 0, it would like jump around 0, 1, 3, 0, 1, 2, like that. It's not perfect. So when you're telling it to be exactly a certain number, it's not the best way to do this. You want to give it like a range so that even if there's little noise and stuff, it would still work fine, right? So you want it to be something like not 256 exactly, but what if it's like in between 250 and in between 260? Any number in between there, move to 40. You know, so these are little things that will make the whole performance of it even better. So we'll save that for later videos, but for now, have fun with this. You know, as you can see, we spent all that time making that kind of complicated code. We went through all of that, but that makes this part super easy, and hopefully you can appreciate the process. So have fun with that. If you have questions, feel free to reach out. I will talk to you later.